Dear students, let's get started with today's class. The topic is correlation and simple regression. At first, I request you all to go ahead to your canvas and open this page. In the initial part, I'm requesting you all to watch this 11-minute video that gives a very good background information of what correlation is, and with some very good visuals provided in this short video. I'll just pull that YouTube link. So yeah, this is a short crash course as a type video. It explains very well about what a correlation is, what are the three different types of correlations, positive, negative, and no correlation type of data. It gives all the required basics that is a must before getting started with today's assignment. And again, this is like they call it as a crash course, in depth. This topic, correlation, regression, is being taught in our business stats 2 class. But as a part of this course, we are just touching the basics. So I think everything is very well covered in this video. So that's the reason why we will be, I request you to watch this and get an understanding. After that, shortly I'll be speaking about getting the data analysis pack for your, for the Mac users as well as PC users. And on that note, here are the couple videos and web links posted about how to get it. I'll be touching the topic shortly. And next, I request you all to go ahead and download this spreadsheet data, and we'll be following with our regular lecture. Yeah, and this is the YouTube video that I have posted. We'll be following. So coming back, once your file is downloaded, please go ahead and open it, and you should see this sheet has 5 different tabs: correlations, spurious correlations, tool pack, Ann Arbor rental, and wage data. The last 2 sheets are the actual sheets where the data is provided respectively for the rental and wages. Towards the end of this class, or maybe after like initial 15-20 minutes, we'll be deep diving into this and solving each of this assignment one at a time. So yeah, these are the 2 main assignment files. The initial are more of a theory that I'll be talking. The very first is getting the data analysis tool pack. Again, we did this last time as well for the window users, but yeah, maybe I'll just refresh where we are at. So if you go in your data tab, for the students who have already installed, you should be able to see on the far right hand side, you should see this analyze sub tab, and on top you can see this data analysis solver. If this appears, meaning you are good to, the tool pack has been installed, activated. If not, for Windows user, this is what you do. Go to your file all the way down to your options, and then if the very first you'll be seeing is general, then go to your add-ins, and you see this analysis tool pack. Select that and go over here and select go. Currently I have selected all of these. The one that we need is the very first one, analysis tool pack, but it won't hurt to have all these 4. And I doubt we'll be ever using Euro currency tools for this class. But yeah, if you want, go ahead and select all of them and click OK. And if you haven't downloaded it yet, activated it yet, it will take like a couple seconds to for this to appear. And go home and come back data, it should appear over here. So this is for the window users. For the Mac users, please go to your tools tab way on the top, and within tools, the downmost, the last one says add-ins, and once you click that, a sub window like this must appear. I'll say go ahead and select both of these and click OK. For most of you guys, it should appear right away. If it doesn't appear, do it one more time. Go to tools, add-in, same, it should be selected, but again, like make sure it's selected and click OK. For some guys it appears during second attempt. To follow through, here are the couple YouTube links are provided. First one is for window users, PC users. Second one is the Mac users. It's a short video, I think 1 minute and 3 minutes. Next, let's go to the correlation sheet. This sheet, I have provided some examples of correlation and what are the 3 main types. On top of it, what are the 2 additional which are also stated as a weaker correlation. So in short, in simple terms, correlation is a statistical measure that expresses the extent to which two variables are linearly related. There are three possible results a correlation study can have. The first one is a positive correlation seen over here. Second one is a strong negative correlation seen over here. And third one is no correlation. And on top of it, there are few in between correlations which are like weaker or moderate correlations. So a correlation coefficient or a correlation analysis helps to understand the strength of correlation that is measured in statistical term. Usually it is referred with the term R, or in Greek words, Greek alphabets, it's also referred as a rho. But in our case, I'm going to say R. I'll say easy to refer. And on top of this correlation coefficient, there is something called as R squared. So we'll be referring that as well. So key property of the correlation coefficient is that its value always ranges from -1 to +1. So this is an example of a positive. So yeah, like everything lies on a single line, and if one of the characteristic increases, the value of one of the characteristic increases, the value of the second character also increases, and all these measured values will lie on a line. So that's exactly 1.0 correlation. And the other side, which is a negative correlation. So oh yeah, so in statistical term, R value or coefficient correlation coefficient value of -1 denotes this type of graph, which shows a negative correlation, meaning if you plot the behavior or the data of two variables and try to identify a relation between them, if one of the variable increases, the other variable decreases linearly. And if all these points lie well in the downward direction, but everything on a if they lie on a single line, meaning they have a -1 R value. So that's what it denotes. And yeah, here are a few more depictions. So this is a strong positive correlation. So like one of the value of the one of the characteristic increases, a variable increases, second one also increases on a very linear way. This is an example of strong negative, meaning if value of one of the characteristic increases, variable increases, the other decreases in a linear manner. Then this is an example of no correlation, meaning if you plot all those behaviors data collected of the two variables and plot it on an XY scale, if you try to fit in a line or a statistical line, you cannot. So that is an example of a negative correlation or an R value of 0. Sorry, not negative, but no correlation with an R value of 0. And here is an example of weak correlation, meaning you can fit in a line, but there is a scatter. And yeah, there are some points which are far away from each other, but again, you can definitely fit in a line. So this is a case of weak positive correlation, and this is a case of weak negative correlation, meaning the points are scattered, but you can fit in a line, and that is decreasing. And here is a moderate negative correlation, meaning yeah, definitely it's not an R value of 1, it's not a strongest correlation you will get, but it is not weakest either, so it's in between. So that's your moderate negative correlation. And something more, again the same type of information from a different source is shown over here. So again, positive correlation, negative correlation, no correlation. And here is the YouTube video that we barely saw. It explains all the basics of the correlation, the crash course. Please watch it on your own time as we go, because I think it's the basics have been explained very well with very good visuals in that short 11-12 minute video. And if you want to read, there is some more theory provided over here in this investopedia.com. And some examples of spurious correlation, meaning well, they did the study, who were like the researchers or statisticians or the data guys who collected the data. They conducted a study and identified some strong correlations. For example, here is the divorce rate in Maine correlates with per capita consumption of margarine. So when they did the study, when they plotted it on an XY, they found a correlation value of an R value of 0.9925 or 9926, meaning there is a strong correlation. So again, again you can do it based on statistical term. You can see there is strong correlation, but it's a spurious one. So again, it can be misleading as well. So this is just an example, a fun type of thing that I thought of presenting. Just to give an example of what this yeah, R value of 1 or close to 1 means. Second is US spending on science, space and technology correlates with suicides by hanging, strangulation and suffocation. Well, I hope nothing like this happens to anyone. But yeah, maybe some statisticians did that study. They plotted these two and tried to identify the correlation coefficient, and they found a strong correlation. But again, statistically, it makes sense, but in reality there is no yeah, nothing like no close relation. And there are a few more examples over here. So if you want to watch or yeah, it is a website, so if you want to see, read, understand, yeah, there are more provided in this website. I will yeah, recommend you to have a quick understanding, so go there and see. Something more is, yeah, we always talk about positive correlation, negative correlation, like strong and weaker and no correlation and so on. So again, looking at these charts, we can tell, and yeah, you can plot a line and you can still tell whether it's a linear, weak, linear or weak positive, whether it's a negative or yeah, strong negative, weak negative, moderate negative, and so on. But it should always be denoted with some kind of numerical value. That's where your coefficient, yeah, coefficient comes into picture. That is, correlation coefficient comes into picture, and oftentimes it's yeah, denoted by some kind of number associated with it. So here are some yeah, like 4 correlation coefficients: R value of 0.65 positive, R value of 0.84 positive, R value of negative 0.02, and R value of negative 0.72. And these are the 4 graphs shown. So if I want to see, suppose, yeah, quickly browse through these. I think this is an example of, you see, scatter plot B. B is an example of a strongest positive correlation. So among the options available, this is the strongest positive 0.84. So I'll say, yeah, to the best of my knowledge, scatter plot B has an R value of 0.84. Then here looks like I can draw it negative way. So maybe this is a negative correlation. Here I see maybe no correlation, you know, something like this, or yeah, something like this as well, these two as well. So if I go and check the options available, maybe this is the closest to 0. So again, not like exactly R value of 0, that is no correlation, but again, this is close enough yeah, among all the 4 options that are given to us. So I'll say scatter plot C has a R value of negative 0.02. Then this is definitely a strong negative among the options available, right? So this is the strongest negative. In this case, the strongest negative value given is R of negative 0.72. So I'll say this is my R. Yeah, this is scatter plot A has negative 0.72, and scatter plot D, I'll say not the best looking positive, but I'll say these points over here, the group, I can draw a line over here. Maybe these points over, I can draw a line over here. So if I draw a line in this direction, again, it's moving like upward. So among the options available, I think scatter plot D has a R value of 0.65. So that's how I will read. Next, we are going to solve the problem on this sheet, an arbor rental. So it looks like some data is given, rental information of yeah, some apartments near University Town, Ann Arbor, University of Michigan, I guess, and something more. So the rental value is given, monthly rent. In this case, we are seeing 645, 675, and so on. The number of beds, number of baths, and square footage for each of them and their respective rent. Next part is, yeah, let's go ahead and familiarize more with the given data. So the very first step is, let's make it much more presentable. So I'm selecting all, centering, adding the border lines and so on. Then the next part is, I'm going to go over here, say view, and freeze the top row. Next, I'm going to go to this data tab, add filters, and let's check the limits. So going over here, looks like the minimum is 645, maximum is 2400. Bed, the minimum is 1, maximum is 5. Bath, the minimum is 1, maximum is 4. Square footage, the minimum is 500 square feet versus the maximum is 4319. So yeah, we check the limits. Always a good habit to check left, right, and yeah, top, bottom, and get an understanding of what the given data sets are. Yeah, how the data is collected. So yeah, this completes our familiarizing of the data, like initial screen data screening. Next one is, yeah, I'm making this bigger. Oh yeah, so this is the same thing we learned like few minutes ago. Make sure you install the data analysis tool pack for Excel. So for Windows users, this is the way you will be getting PC, and for Mac users, this is the way. And again, if you want, I can just, yeah, for Mac users, you go to Tools, Add-ins, and select both of these. Click OK. Yeah. Next, the list of questions. So the very first question that is asked, it says calculate the correlation between square footage and rent using Excel's correl function. Question number two, create a scatter plot of square footage on rent. Put square footage on X and X-axis and rent on Y-axis. Also add a trend line, a linear trend line equation and R square to the scatter plot. Next, question number three, it says run a regression with square footage as X variable and rent as Y variable. And in order for do that, yeah, follow this process. Regression is yeah, go to data tab, data analysis tab, analysis tab, regression, and yeah, select regression and follow the prompt, which I'll be talking shortly. Then finally, using the correlation coefficients from the equation that we have derived using the three methods we learned, what is the predicted rent for an apartment with square footage of 1000 feet? So this is the question that is asked. So let's proceed. For that reason, I'm going to move both of these text boxes to my extreme right and moving forward. So the very first, okay, maybe I'll just keep this visible. So they are saying calculate a correlation between square footage rent using Excel's correlation. Before proceeding, I will just like to bring this to your attention that in business statistics 2 or yeah, some other advanced statistic classes in our university, there are dedicated chapters in regression analysis, correlation analysis. In fact, I have taught business stats 2 multiple times, and there are like 4 different chapters. Technically, I think it's more of a 6 weeks of dedicated study on correlation analysis and regression analysis. So we won't be getting into much more depth. As required, I will be giving some basics every now and then. But yeah, and the reason is the whole correlation and regression are very, very hot topics in terms of statistical world, data analysis world. And with the modernized, I'll say data generation, the data technologies coming, these topics are playing a major role. Yeah, these statistical topics, these are becoming very hot favorite because these analysis tools using Excel or some advanced programming like Python and so on. Yeah, you just have to select the data, understand the data, clean it up, and use the right function. Use the right code, and just it will do the analysis, which you can utilize for making some very good conclusions, making good predictive models, prescriptive models. You can take a lot of corrective actions to improve your business decisions and so on. So, and that's the reason why, yeah, we are including this as a like a very strong statistical concept for this class, and that's why we are following this problem. So just remember, like yeah, quick, I'll say refresher. So we have data set given. The first one is rent. Second one is yeah, some more additive like a bed, bath, and square footage. And we have to use the correlation analysis. So let's complete the first part. Yeah, calculate the correlation between square footage and rent using Excel's correl function. So yeah, maybe I'll just start from here. Say cell H3. I'll type in say correlation. Correlation coefficient. I will make this a bit bigger, and this is what I write. And on top of it, and again, this is nothing but the R, and I'll use comma R. Yeah, but that small r that we learned few minutes ago. Yeah, this is the one correlation coefficient. And on top of it, I'll also add one more. Say R squared. R. Yeah, you can also call it as R squared or R raised to 2, which is nothing but you square the top one. Yeah, there are multiple names to it, but let's stick with these. So starting with the very first one, that is yeah, correl function. So this is the syntax you use. So equals to CORREL. So this is the one. I'll select it, then it is asking me yeah, so it is telling there are 2 sets of arrays that we are supposed to enter. So it is asking for the first array. So again, I'm trying to find the correlation between square footage and rent. Yeah, so this is my square footage and rent. So I'll just go ahead and yeah, use the first one, which is yeah, let's start with the rent. So Control Shift down, and then I'll say comma. Then it is asking me what is my secondary. So I'm doing this. Select this one, Control Shift down, and I'm closing it out. Enter. So yeah, it is telling me yeah, the correlation coefficient R for these two variables is 0.83925. Yeah, so the first part is completed. Second one, it is asking for R square, or yeah, so all you do is equals to, go to this number, use this caret symbol, raised to 2, enter. So it's 0.70435. Yeah, so technically we completed the first analysis. And something more, let's yeah, as we go, I'll explain what these means in statistical terms and how it is important. So based on these numbers, what inferences, what conclusions you can make based on, yeah, these numbers, like correlation between rent and square footage. Is it one-on-one? Is it directly proportional? So is it true that uh, as your square footage increases, rent increases? Is it a direct correlation, or there are some other factors also? Yeah, so I'll be talking about it shortly. For now, yeah, just bear with me and let's take a pause from this topic here. Then the next part, it says create a scatter plot of square foot on rent. Put the square footage on x-axis horizontal and rent on the y-axis vertical axis. So yeah, let's continue. And on top of this, the second part will add a lot of value. It will help you understand the overall scenario, data scenario correlation, statistical inferencing very well. And this is the fun part. Once you start seeing those charts and those lines, and then you add equation, you add the R square, you will be able to make a lot of sense, lot of I will say objective, quantitative decisions or inferences based on what we do here. Yeah. So for that reason, let's go ahead. Yeah. So create a scatter plot. So next part. Yeah. Go over here. Say click on insert, and well, in PC or Windows user, this is where it should be. Yeah, if you are using Mac, maybe here it is, or go to recommended charts. Oops, sorry. Or go to, oops, I'm getting the create, just select the cells. Okay. Yeah, for that reason, yeah, it is asking me to select the cells. So what I'm going to do is I'm just going to make this selection from top to bottom. So cell A2 until all the way down. Then I'm going to hit control. If you are using Mac, use command. So click on command and then control shift or command shift down. So you have selected these two groups of cells, yeah, starting from A2 all the way down and D2 all the way down. Now I'm going to go here, say recommended charts, and and then go to all charts. And here, can you see this XY scatter? Go over here, and within this, select this one. Yeah, say OK, and this, and yeah, boom, you get the XY scatter plot. So they are asking put yeah, square footage on x-axis and rent. So looks like that this is it. Oh, sorry, it has a reversed. So in order for you to do that, yeah, let's right click on here, say select data. Yeah, you see this switch row and column. I'm going to click over here, and maybe when you, oh, sorry, yeah, something is, yeah, old range is this, new range is this, no worries. Yeah, let me just do it manually. So I'm going to click over here, edit. Now it is selling the x axis value. It is telling this is my x axis value, and here it is telling square footage must be on your x, and here my rent is on the x. So all I'm going to do is just select it, delete it. I'm going to go from top to bottom. Done. Then go over here, delete this all, and then select my rent. Go over here all the way down, select, say OK, and you see what happened over here is, oops, so this is square footage. Yeah, that's correct. So we don't need to do this. We'll name the series shortly, but I just wanted to show you what I did over here. So coming back, yeah, here I'm seeing the rent value on my y-axis and square footage on my x-axis. So this is exactly what I wanted. The next part is let's name it as yeah, let's give it a name. Say sc scatter plot. SCATTERPLOT of a square footage versus rent. So I'll say SQUARE versus rent, and I'll click outside. Then I'll select this all. I'll go over here, bolden it up. Currently it's 14 selected. Let me make it say 16, or yeah, I think yeah, 20 is good. 20 looks good, very presentable, very big. Yeah, so this part is also completed. I will close this window that popped up randomly. Then let's go ahead and name the X and Y axis also. There are two ways to do it. First one is just click anywhere on the chart, and yeah, you see three small squares will appear. Click the first square that has a plus sign. When I do that, yeah, a small window like this pops up. I will go ahead and select say axis titles, and once I do that, I can go over here and manually add. Let me show you the other way. So this is one way. I'm unselecting it. It went away. Then again, select anywhere over here, and you see like when I haven't selected or clicked anywhere on the chart, I don't see any extra options on top of here. But as soon as I click that, you see a chart design and format came up. So I'll select on this chart design, and on the extreme left hand side, can you see this add chart element? I'll make this bigger, and then it says axis. It is telling yeah, primary so yeah, horizontal and primary vertical. Then the next part is our like yeah, the feature of our interest, which is axis titles. We are going to do both, yeah. So primary horizontal, primary vertical. Here yeah, you can select one at a time. So I'm selecting primary horizontal. I'm going over here and I'm going to say this is my square footage. SQUAREFOOTAGE. Yeah, click outside, select on it, and I will again make it bold. Let's type bigger one. 1, 2, 11, 12. Yeah, I think 12 looks good for the title. I'm going to do the same thing. Click anywhere on the chart, then go to chart design here, axis title, and I'm going to select vertical. Yeah, so this box popped up. I'm going to say this rent. Yeah, rent, monthly rent, or yeah, just rent is good. That's what it says over here. Rent. Yeah, RENT. And I will also put units. Always the best practice to add units wherever necessary. Here, yeah, square footage itself is a unit, I will say. Yeah, so it's like foot square. And rent, I put dollar. Taking it out. Then again, selecting this, going to home, bold, and let's use consistent, which is 12. Yeah, 12 looks good. So both of these are good. So this part also completed. Few more things is yeah, I think there are too many of these grid lines, so I'll select this say vertical. Yeah, click on any of this grid line vertical and click delete on my keyboard. Yeah, it goes away. Yeah, now it looks much more clean. If you guys want, if this is looking much more messy, you can also remove these if you want. Even if you don't, I won't yeah, deduct points. But yeah, this is yeah, what we got after removing all of those. And since those grid lines went away, this looks much more cleaner, maybe overly cleaner. So I click somewhere over here, go to chart design, maybe not this option, change color. No, let's go to format. Oh, awesome. So shape fill, shape outline. Yeah, let's go to shape outline and add this. See what we got. Oh, awesome. It gave an outline. So I think yeah, this will look much more presentable now with this outline. And it's my practice. I also try to add an outline. You see currently it's grayed out. I like to add a outline on the outer chart also. So I'll go over here, shape outline, again this one. So again it got an outline. So it looks much more nicer now. Now they are asking us to add a trend line, linear, also add an equation and R square. Hey guys, so yeah, you must all thanks, you know, in statistical world, all these hardworking people from, I'll say, yeah, the coders, developers of Microsoft Excel 365 and all those new features that have been created. Yeah, thanks to them. I mean, that's one of the reason why, you know, using this statistical analysis, using Excel or many other software packages has become easier because of all these added features in Excel. Yeah, so I'm going to show you one and then I'll explain what. So for that, all I'll do is click on or maybe hold my mouse on any of these points, then right click on any of the point. And yeah, you can see some options like a window like this pops up. In fact, two of these like pop up. And on the bottom, can you see this say add a trend line? Go ahead and click on that. So I added a trend line and by default, a window like this pops up and by default, yeah, And so the selection will always have linear most of the time, unless you are working on yeah, this analysis, and if you have selected something else, it might go with that. But yeah, linear trend line gets added. And if you're doing advanced statistics, maybe you want to use exponential trend line. Maybe you want to use a logarithmic. You want a polynomial power moving average to yeah, to moving average and so on. And yeah, like I think business stats 1, mostly like business stats 2 covers all of these functions. So yeah, if you take those, there will be some of the part of the chapters where they will be learning about these. But yeah, for now, let's stick with our linear. So yeah, because it has asked. And the next part is equation. So if you go below over here, it is saying display equation on chart. Hey guys, thanks to this one check box, this makes everybody's life easier. So checking this, you can see how the equation is appearing over here. It says y equals to 0.552 times x plus 512.98, and it also says display the r squared value on the chart also. Yeah, so I'm going to click this as well. So when as soon as I click that, you see r square appeared. So this has made, like, statistical life, like lots of life of lots of professionals who are using data on a day-to-day basis to make some predictions, generalizations, understand the effect, how much confidence do you have in the collected data, and whatever analysis you are doing, whatever predictions you are doing, how much you can rely on those analyses and so on, has become very easy, or I'll say, yeah, very much feasible for most of the professionals thanks to these extra features. So as professionals, our job moving forward, utilizing these features is just to understand how to read these numbers and make the conclusions. Yeah, so again, previously, like I will say before 2012 or 2008, 10 and so on, you literally had to do the statistical analysis. Yeah, you have to get on averages, get on the standard deviation, then you had to use the yeah, the correlation R function. Again, there is a very difficult type of statistical formula, you have to derive that, and then you used to get these R values and R square values, and based on that you used to do all this analysis. But these days, just make sure your data is clean, make the right selection, draw these kind of charts, and it will give you the analysis. Yeah, so this is your analysis we are getting by default from Excel. So your job is to understand these and use that information to drive your future decisions. Yeah, so coming back to our main problem, so I'm going to close this. Yeah, so linear line done, equation got, r square done, and if everything is right, yeah, this r square must match the r square that we calculated using the Corel function. So again, if I see over here, yeah, looks like it is matching. Here they have like 4 decimals, right? I will use the same 4 decimals for both the cases. So I'm going to select both of these and reduce one. So 7043, 704, awesome, looks good. So yeah, I will repeat again. If everything has that you did is correct, then these numbers should match, which is happening. So yeah, that tells us that everything we have done is correct. I'll make it bolder, much more presentable. Let's stick with our standard 12. I think yeah, 12 is the number we used. So that yeah, it's bigger and readable and it's obvious, yeah, on the screen. So this part is completed as well. Now the next one, the third way of calculating the correlation R and R square. That is run a regression with square footage as X variable and rent on Y variable. Regression, and yeah, how to do the regression in the the data analysis tool pack is, yeah, go to yeah, your data tab. So go over here, then select data analysis on the extreme right hand side within analyze. So select this, and within that select regression. Yeah, so let's follow that step. So yeah, again we are here, data analysis. Then once you click that, you can see that these are all the types of analysis which are a part of the data analysis tool pack. And third time I'm repeating because I have myself used this function on lots of real world situations, and it makes everybody's life very easy. Yeah, so your job is to understand how to read it and take it forward. Yeah, so within the these are the different types of analysis, statistical analysis as a part of the standard data analysis tool pack. So you can do ANOVA, single factor, two factor, replications, non-replications, correlation, covariance, descriptive statistics, exponential, smoothing, F test, Fourier analysis, histogram, moving average, and yeah. And towards the end, like if you go all the way, here is a regression. That's what we are going to use. So I'm going to select that and click OK. Another window like this will pop up, appear. So yeah, let's read and familiarize what the content of this is. Yeah, again, what are the most important things that you need to fill out? There are some things we can leave as unchecked, and still you will get the exact analysis. So the main things to fill out is this: input y range, meaning what is your y; input x range, what is your independent variable, dependent variable, and the next one is yeah, select labels and all. So if you select this data and include this label, you check mark this. Same in y, x also, both of them you have to be consistent. So if you select the header, then you will select this, it will differentiate. There are, just like pivot table, you can select an output range where you want that pivot table or your regression output. You can also have it in a new worksheet, like we did it in pivot table also, it opens in a new worksheet, or you can open it a new workbook file itself. These may or may not be required. Well, today we are not going to use any of these, but if you're doing some advanced statistics analysis, you might have to use these. Yeah. So as you go, maybe in future you can try these out. But for today's analysis, yeah, we'll be using this, and let's go with our yeah, output range. I think that's the only thing that is required. So for that, for my y range, so as we saw here, our y range is your rent. So I'm going to select this y rent is my rent. So this is, and again, like I said, I'm going to select all from the header as well. So I'm just going to select all of these manually. Click back over here. Now it is asking for x range. So we know our x range is a square footage. Go over here, select from top to bottom, and then I'm going to say labels. If I don't, then you see what happens. It is telling that output range missing, please enter. Yeah, so it identified some text character which is not able to recognize. So I'm going to click OK, and now I'm going to select this labels. Oh yeah, output range is, yeah, it's also asking. So I'm going to say I want my output range over here. Yeah, just below this chart. So selecting this, and I'm going to say here and click OK. Awesome. Yeah. So here is my output range. So now let's read through. And if you take our advanced statistics class, that is your business stats 2, we do teach what is the structure of this output summary file from a regression analysis, and what is the meaning and importance of each and every term that you are seeing over here. So again, as an output file or summary file, yeah, these are the three tables you will get. And yeah, first one is regression statistics, second one is an analysis of variance, which is ANOVA, and each of this has some importance, some significance. Yeah. So the very first important thing which usually I teach in my business 2 is, yeah, let's go ahead and read these two numbers, which is multiple r and r squared. And again, let's highlight this with yellow because this is a key output we are looking at. Second one is this one, that is a part of that equation we saw, and few more. Well, this is also important, but we won't be utilizing that a lot. It also is important. So yeah, let's read the first one, r squared. Yeah, so 0.7043. Yeah, so again, this is matching with this one. So that tells us that, you know, this one as well. So that tells that even you know, whatever we have done over here is correct because all the three answers are matching. And if this case we are only having one factor as like square footage, and that's why like, yeah, the r square we are getting is just a straight away square of square root of this, which is 83925. So yeah, that's the yeah, number we are seeing over here. So again, this shows that our analysis is correct. And the next part is you see the equation, and again, we haven't discussed the equation yet. But again, these are the two entities. Yeah. So again, the equation we are seeing, this linear thing, is y equals to 0.552 times x plus 512 times 512.98. So again, this is just our you know, the algebraic equation, like y equals to ax plus by plus c, or in this case it's like y equals to ax plus b, which is your constant. So ax, yeah, x is your one of the variable on which your output is dependent, and these are the two constants. So yeah, these numbers are the same as these one that we are seeing. So yeah, so by doing this, we completed you know, the first part, second part, third part. Now let's go ahead and understand what some of these entities mean. And for that reason, yeah, I'm just going to pull a couple of more things. So again, variable on x-axis, variable on y-axis. Yeah. So again, this is more of a statistics, and if you take advanced statistics class, it will already be covered. but your X value, yeah, usually in statistical world it is, yeah, if you're, especially if you're looking for correlation or regression analysis, your X is your predictor value or independent variable or control variable. So this is something that will have some level of effect on your Y, yeah. So by using this as one of the key parameter, key variable, you collect data, and then you check if there is a like correlation or not. Yeah. So currently we are seeing this R square as 0.7, and here what we learned, or even our advanced statistical classes, what we learned is the value of R ranges from -1 to +1. The value of R square. So if I square this one, it becomes +1, right? -1 is square is +1. So the value for R square always ranges from 0 to 1. So if I look at this value 0.7, so again on a on a scale of 0 to 1, this one like more weight towards one side, right? So again there is more like I say moderate level of correlation, not very strong, not very weak, but or no, like not a case of no correlation at all. Definitely there is some level of correlation. It's not the strongest. If it was 1, theoretically it's the strongest. In real world, anything above, I will say 0.9 or 0.85 is considered as a very strong correlation. So this is 0.7. So this is more on a moderate side, but yeah, definitely there is some effect of square footage on the rental amount. So this is what it means. And yeah, the next step, well, when we plotted this scatter plot, yeah, and when we added this line, regression linear, yeah, regression line, trend line, we saw that you see like Excel did it best. Yeah, so again behind the scene there are lots of theories embedded within the Excel code, so it will do its best and give you a trend line, and you can clearly see that this point is an outlier. Yeah, so if suppose you are doing this data cleaning, data manipulation, or trying to understanding the data, and based on whatever feedback or whatever experience you have using your own data or your company analysis and so on, if you say this is an outlier, and say I'm taking it off, yeah. So again, let me point it out where it is. So it is telling it's 4319 and 2200 are the data points on series 1, which is the current series we are seeing. So 2200, if I go over here, so yeah, looks like this is the data point. Just I'm just doing this, I'm deleting this part, and as soon as I do that, you see the whole chart is readjusted, all the data points are readjusted, the scale is readjusted, and you see that point is gone, and you are seeing a new trend line, and your R square, previously it was 0.7 something, now it has improved from 0.704 to 0.85, meaning yeah, that definitely was an outlier. And if we ignore that one point, which was dragging this line down and which was lowering your R square value, so definitely it's an outlier based on that analysis. So yeah, if I take that off, this is my improved version of R square. So yeah, this is one way to do the analysis in real world, but again, you have to have a strong understanding of your own data, and you must be keen, very sharp about identifying those outliers. Some of the outliers might be very close to the entire group. So again, you have to be that like sharp and keen and know exactly what could happen and what to expect and so on. Based on that, you make a decision whether or not to eliminate that point if you think it's an outlier, or your team or bosses think it's an outlier. So yeah, this is one way to do the data manipulation. So coming back, hey, one more thing. So other thing is, if I take that outlier out, so this R square I got, I can strongly say like 85% in this case. Yeah, I mean not in the previous, which is 70.4%, but here I can say 85% of times, or there is 85% chance that the rental value of a given apartment is solely dependent on your square footage. Yeah? And the remaining 15% might be some other factors like bed, bath, or maybe how close that apartment is to say a bus station, or yeah, some other factors. Yeah, so 15% there is some other factors affecting, and 85% strongly it's the rent is strongly solely dependent on your X factor, which is your square footage value. Yeah. Yeah, so this is just an explanation. So I'll say Control Z. I will still keep that data point. Yeah, so I don't want to lose that. So once I do that, yeah, I get my original R square, and here also it's updated. It's a yeah formula based. Yeah. So this is about the X axis, meaning it's one of the predictor variable. and we assume that they are predicting the variable on the y-axis. So in this case, square footage is strongly predicting the rent, and yeah, that's the other. So this is your equation, and again, the only variable is your square footage over here, which is your x. Next thing, I will move this away for now. Next part is your y variable. Yeah, so in statistical world, the y variable is your outcome variable. So it's a dependent variable. It's a, yeah, also called as y variable. So this is the yeah, in a linear equation or in any if you can have exponential multi power and so on equations as well. So in that case, y is your outcome variable. Yeah, so again there will be an equation that will be deriving using statistical analysis, and y is the main output you are looking for. Yeah, so x is one. In this case we only have one x, but there can be multiple. So x is one of the input that will have effect on the output, yeah, which is y. Yeah, so that's yeah, that's statistical terminology. Now coming back over here, something more is yeah, I think yeah, we completed 1 2 3, and I think yeah, this whole analysis is very important. Let me add some more description so that you can make a note, and this should stay with you forever. Again, I strongly say yeah, practice more, read, understand more, but this is one of the simplest feature, yeah, Excel has created, and that's one of the strong reason why statistics, which is, I will say, advanced analysis, is considered like more of a tougher topic in, yeah, like in not only in colleges, but yeah, for real world professionals who rely on lots of data to make decisions and so on. But thanks to all these methodologies like, yeah, scatter plot, this adding equation r square, as well as this data analysis tool pack, as well as this feature, your job, well, Excel will do all the hard work for you, so you don't have to remember those difficult formulas, enter those numbers and derive the numbers, and based on those numbers you make, so that time is saved. It will completely give you the analysis, and your job is to understand how to read these numbers and make the conclusions or inferences from the given data set. So coming back on that, let me add a little bit of theory so that you guys can remember this for a longer time. So on that note, I'm going to go to insert. Let me add it over here. Say text box, and I'm going to add a text box over here. So I will just try to fill this screen, this part of the screen. So select this, and I'll use this. Yeah, I prefer yellow because it stands out. And yeah, maybe I'll take it a little bit upper so that I can read those r square values and so on. Well, I mean, it's available over here, but let's try to use a chart as well. So here, so the note I'm making is the r caret, yeah, r square equals to 0. Or 70%. Let's use the number we get, 0.7043. So which means that the variation in SQUARE FOOTAGE EXPLAINX explains 70.43% of the variation in rent, yeah, rental value. More generally, yeah, so more r caret 2 or r square tells us how much of the VA variation in the y value that is your outcome variable is explained by variation in our x variable, yeah, that is your predictor variable. Yeah, so this is, I will say, one of a very good explanation. And yeah, remember this small sentence over here, whatever, well, firstly, you have groups of data, lots of good data, systematically collected data, cleaned up, and yeah, you do this analysis at the scatter plot or this, then you get these key statistical numbers. Your job is to remember this, and again, it's not going to change. Yeah, so how to interpret, read and interpret this r square or just r, or this equation is forever going to be the same. Yeah, so again, remember this, and next time you see any set of data, you can do your own analysis, and your job is to get these numbers or these equation like this and make the interpretation. Yeah, so again, if this is let's say high, like greater than 0.85, or even better, like if it is 0.9, then there is a strong correlation. So you, yeah, the analysis you are done, yeah, you can make some predictions, because I'll say if this number is say 0.9 or 90%, it means that 90% of the change in rent is dependent on the square footage. Yeah, so again, change in y variable, output variable, dependent on this x variable, in this case square footage. But on the other hand, if this is like 20%, it clearly tells that only 20% of your r square, yeah, or your rental value is dependent on your square footage, and 80% there are other factors. Yeah, so again, if this is so low, meaning it's a case of a weak correlation, so I won't continue with my predictions. Yeah, if that number is low. Yeah, so that's how you interpret. So with this one statement, I'll say remember this forever. This will benefit you in a longer run. Yeah, big time. Yeah, so this completes my first one. Next one, let's focus on the equation that we have derived. So I'll say y. I'm just going to rewrite it. Yeah, so what we see, and again, I'm just going to in the write in the form of y equals to a plus by, something like that, algebra, simple algebraic form. I'll just yeah, use the constant first and then the actual multiplication term. So I'm going to say equals to this number 512.512.98 plus 0.552 times x is our regression equation. This is called a linear regression. Well, one thing is, it was when we were picking selecting this, it was written over there as linear. Other way to look at it, you see the coefficient, or sorry, the power of x here is 1, right? X raised to 1. If it was x squared, then yeah, it wouldn't have been linear anymore. It's also called as OLS, or ordinary least square equation. So just write or OLS regression. So I'll say OLS equals to ordinary least squares. And technically, the line we are seeing, or the equation we are seeing, is the line of best fit. Yeah, so yeah, of like different people, different statisticians, different person might call it differently. Some guys might call it as a OLS regression, some guys might call it linear, or some guys might call it as a best fit line or best fit line equation. Indirectly it means the same. So this equation, linear equation, or what it tells you is that this line will minimize the distance of each of this point from the center. Yeah, so in other words, this is what it is. So yeah, technically all the points you are seeing, it will do its best and maximize, or sorry, minimize the distance from each of these points from this line. Yeah, so that's how it will plot a line. So yeah, to the best it can, it will minimize the length of each and every point from this line itself. Yeah, so that's the meaning of this best fit line. Let's add something more about the equation and the explanation with respect to this rent and square footage. So yeah, the top sentence is more of a theoretical. We just replicated and add some more theory, technical terms, statistical terms. Now let's say our y, which is rent, equals to, I will use $512.98 plus well, yeah, still say 0.552 multiplied by my square footage. Yeah, SQFOTAGE. So in other words, for each ADDI additional square footage, we would predict rent would increase by $1 0.552. Yeah. So for every additional square footage, uh, your rent will increase. Increase by $0.552. Yeah, this is what it means in the second part of this equation. So for example, for 100 skew UA, or let me use a short form skew foot, I increase, we could, or say let's we would, no, yeah, we predict rent to increase by $55.20. Yeah. So this is how I got. Yeah. So for every 100 foot square footage increase, I'll multiply this 100 with 0.55 to this value. So that's how I got this 55.2. Yeah. Yeah, so again, this is very like important. Again, these couple sentences, yeah, this basic theoretical information with some numbers we used on R square, and this also, although it looks very simple, this is a very important lesson, key takeaway from this class, and I'll say this regression analysis using three different ways in Excel, and how to read these R square as well as this equation is what we are learning at the moment. So something more is say if this were a cost function in accounting world. So I'll just write in terms of accounting, say cost of a given quantity Q equals to $512.98 plus say 0.552 times a given quantity, then the $512.98 would be my fixed cost that is cost that don't vary with output. Oops, sorry. Yeah, suppose I opened an office. Yeah. So for that office, I will have a real estate. Maybe I either purchase a whole floor in a big office building, or maybe lease it. And yeah, it might be an annual lease. So again, once I sign the contract or purchase it, that's a lump sum I'll be paying. Yeah. So suppose I paid like a couple million on the whole floor. So that, yeah, that's a fixed cost. Yeah. So that's what it means. Or suppose I purchase some computers, some hardware, some other software, some furniture. So again, that's a fixed cost. It is not going to change anything based on the quantities I'll be selling or service I'll be providing. So that's my fixed cost. And the remaining, yeah, so that is $0.552 would be the variable, that is the cost of producing one more quantity or item being sold. Yeah. Yeah, suppose say, yeah, well, again, if I open an ice cream store, say, so I'll be maybe purchasing a like whole land, real estate, building a building, and whatever the table, chair, ice cream makers, and so on. So that's yeah, the initial cost I paid to set up the whole store will remain the same, and say ice cream. Just for your reference, I'm adding. Yeah, so ice cream. Yeah, say one more item being sold, or one more ice cream. Yeah. So even if I sell say 1,000 ice cream per day or 10 ice cream per day, my fixed cost is going to remain the same. So that's what it means. And the second part, which is 550, 0.552 Q, will change. Yeah. So if I sell 100 ice creams per day, I'll multiply this with 100. If I say 1,000 ice cream per day, I will multiply this with 1,000. Yeah. So yeah, this is exactly what it means. So I think, yeah, these are some statements I want you to review and make a note, and yeah, just remember it forever. Now the next part is, yeah, so it says using the coefficients from the equation, that is this equation, what is the predicted rent for an apartment with 1,000 square feet? Yeah. So again, the quick way is there a number 1,000? Oh yeah, it is 955. But yeah, let's actually solve it using the equation. And again, like yeah, I mean what I said is was a shortcut, but it won't be like always. So better we come up with some actual equation within Excel. And again, Excel has that feature where you can add any equation. So this is more of a comparatively very easy type of equation. So let's go ahead and build it. Yeah. So this is going to be your fourth. So well, yeah, I'll see y t e r c e p c e p t. Well, before that, maybe we can quickly review and then I'll explain what that intercept is. So you can here you can see in the regression analysis the tables that we got, the output summary we got. Here are the coefficients it is telling, and these are the intercept it is telling. So your intercept, it is your constant, is your 512.98, and square footage, that is your the multiplying factor for x is 0.552. So yeah, these are the two parts of the coefficient. And if there are right now we are only having one x variable, that is square footage. If you have multiple, yeah, so if I had added a bed, bath, or yeah, distance from a bus station, or whether the I'll say rental apartment was furnished, unfurnished, or whether it was like yeah, newer, older, new features, cable internet added, and so on. Those factors, if I had like 5 or 6 different more factors added over here, and if I had selected that within our regression, I would have got square footage, bed, bath, furnished, unfurnished, new, old, internet or appliances, or distance from bus station, and so on. I would have got all the list of those as well as the coefficients for them, and I would have gotten a very long equation. Instead of this simple equation, I would get a multiple of them. But using a regression, that is easily feasible. Yeah. But again, this is more in this class we are learning more of an analysis part and not on the hard statistical part. So we'll focus on what we are doing right now, just one variable, input variable. So coming back, yes, let's see what the intercept is. Other way to describe that intercept is, you see, I will go over here, say I select this, and oops, I want that equation line. So I'm still not getting that. Let's go. I'm clicking anywhere over here and say add a trend line. When I do that, oops, it is trying to add another, which I don't want. Oops, yeah, let's go over here, say trend line. Well, it's still the same. I'm going to select should have written, no problem. Let's redo it. So go over here, add a trend line. So linear is good. I'm going to say here display equation this. Then I'm going to standardize. Again, nothing is going to change. So let's make this standard bigger. 10.5, 11, 12. Yeah, this is good. So yeah, the same thing. Yeah. So when I do that, I am getting that equation. Oops, sorry. Getting that equation. I'm going over here. Oh no. Some equation, make it bigger, older. Well, move it over here. Go to the equation. Oops, sorry. When I do that, I'm missing that out. 1 point. Select that again. Okay, just let me know. Add a trend line. Right click, then display this. And here, if you check, you're seeing this like set intercept, right? And if you go above, you can always see, you can also see that, forecast either forward or backward. So if I select, say, backward, and here it says 500, right? It starts with 0. So if I say backward, yeah. So this is the last point. It is, extreme left point or the minimum point that it identified. So from this point, yeah, from the linear trend or trend line it has plotted. If I say I want to forecast backward, but again I'll be using 500 as the number. And again, I'm not putting negative because it's already stated backward over here. Oops, sorry, my number lock is on 500. If I do this, you see it intercepted over here. And yeah, so in simple words, this intercept or this number 512 over here is nothing but when your x value is 0, in this case, square footage of 0 doesn't make any sense, and I don't know how it can be 500. But again, this is based on the data collected. This is the linear trend, and again, it is what it is, and this is true reality in uh, statistical world, that at a given value of x, the y value you get is your intercept. Yeah, so that's what it means over here. So yeah, this is something I wanted to show you. So coming back, and you can do the same, like I mean, this isn't really related to any of your intercept, but you can do the forecasting also. So forward, if you want to forecast, say I want to say forecast, say if I had a square footage of say 10,000, what would be the value? Yeah. So again, if I want to know that value, so again I lost it. Awesome. So I'm taking it to 0 again. I don't want any backward forecast. And if I see 10, 0, 0, 0, 0 square footage, what will be my value? So again, it predicted, and this is, yeah, when I will, yeah, just plot it, map it on my X, and it will say something like, yeah, so 10,000 square footage. So the rent will be somewhere between 8 to 9,000, maybe 8,600 ish. So yeah, it is doing the forecasting here as well. So for now, I'll just make it 0. I just wanted to show you that there is this forecasting function also. And yeah, using the backward function of 500, which is 0 here, I wanted to show you what the intercept is. So assuming your x value is 0, meaning your square footage is 0, the point at which this line will intersect your vertical axis is your intercept. Yeah, so this 512 is this one over here. Coming back, so this is a part of your equation. Going back, yeah, let's make this turn bold, up 12, perfect, move it a little on this side. Present table, coming back here. So now I'm just saying my y intercept, this is equals to, I will say 512.98, enter. Then is my square footage SQ, yeah, I will say equals to $0, and this is also dollar. Let me add that 0.552, and then third one is my say predicted rent. And once you have an equation, this is always a good practice to come up with a simplified tables like these, so that if like what if scenarios are given, in this case it's telling what if here square footage is 1,000, what is the predicted rent? Yeah, you can always come up with like this and have a standard small table equation built in available. So just plug in that number and you will be getting that number, the answer, predicted rent. Yeah. So in this case, this value will say, in this case, yeah, let me use one of the, say 500. Yeah, just I'm using this first number, and I'll tell you why. Yeah, we don't have to do anything here, but yeah, say 500 is my x value, and this is my, based on the equation, multiplication of y or of x, $0.552. So I'll say this equals to part of my equation multiplied by the x actual value. So 276 is my value, and my this predicted rent equals to this value intercept plus my actual calculated value, enter. Yeah, so in this case 788. Oh, sorry, this is square. No worries. Coming back, and yeah, the number that we will be manipulating, I'm highlighting that by yellow. Sorry, I don't want the top one. So 1, 2, 3. Oh, sorry, 1, 2, and control or command 3, and this also say yellow, and this is yeah, let's add these dollar value to it. Dollar value. Well, this is also, yeah, this is also calculated dollar value. Do I really need double decimal here? No. 0. Here we are using 3, right? 552. So let me make it bigger. This case here, yeah, I think, yeah, this is good enough. Sure. So let me check here one more time. So predicted trend, and again, this is your the final value. I make it bolder, make it this way, or maybe I use a light green color so that I know this is my answer. So my y-intercept multiplied by this into x value, which is my square footage, and this is my calculated. This multiplied by this gives me a predicted trend of this, and this is based on this equation. Yeah. So this is done. So again, my question here is using, oops, let me make this, take this away. Using the coefficient from the equation, what is the predicted rent for an apartment with 1,000 square feet? So if square feet, oh, sorry, yeah, this isn't dollar. This is my square feet. I will take the dollar off. Oops. Yeah, let's do this. Yeah, so if it is 500, this is my 000, then my value is, again, if you see these, meaning the content or the number of characters in this cell aren't able to fit in this width. So I just make a double click here, the width will readjust. So yeah, based on the equation, my predicted trend is this much. Yeah, and again, if you try to match these numbers over here, this is the data collected, and this, based on all these data collected, you have made a predicted value. So the numbers you are seeing over here highly likely may not exactly match the number you are getting, because this number is based on the equation. Yeah, so again, the starting point was this. Based on all these data points, you derived an equation, and then you are driving the equation. And again, within this equation, or this line plotted, you are seeing there is a gap between each and every point of this. Yeah, there might be some points on which it is exactly line. Well, those are those 1z 2z points where yeah, you might get the same number if you plug those numbers in the equation, but don't expect the exact number to be entered. Yeah, well, closer this point is to this line, well, less amount of deviation you will find, and far away, the farther this point, more away of deviation you will see. But yeah, those numbers will never match. Yeah, so again, this is something, yeah, we call this. So if I put this 800, I'm getting 954, and if I'm putting, yeah, I think the 1,000 is what we are asking, 1,000. So yeah, the predicted rent is this. Always a good habit based on that, the equation that you have derived, to come up with simple small table like this, in which this is your intercept, this is your square footage, meaning one of the variable, which is the multiplier of this x variable, and then have a floating x variable where you can change these numbers, and have a multiplier of these two right next to it, and have a predicted value, which is nothing but the equation, which is this intercept plus this gives you the final y value. Yeah, so with that, we completed this part as well. Yeah, hope you all enjoyed doing this, learning about this using the statistical concept, plotting data, analyzing the data, and coming with an equation, and using that equation to solve more problem. So this is exactly how you will apply, and this is one of a strong reason why the usage of statistics and more analysis, like data driven, is becoming much more easier, because yeah, thanks to yeah, like all these features available in Excel as well as other software packages. It has made the statistical analysis much more user friendly, easy to understand. Your job is to only interpret these numbers, what these number means, and what is the range we are looking for, and based on the equation, how to proceed. Yeah, and so on. With that, thank you so much, guys. Have a very nice day. Bye bye.